All right, recording is on. We'll get started. There weren't any other agenda items added besides the two that I had added, and I think the only thing that we really had outstanding from the last meeting was kind of discussing the CRD initial proposal, which I sent out earlier this morning. Sorry about the short notice on some of that. But it is basically the same as what was in the agenda doc for the last meeting back on I think the 21st of December. I have been updating that today based on all the comments, and I think, let's see, Mike, if you're on, I addressed your comment, which was a good point, about your comments about plugin. And let's see, is Corral on? Yes, you are on, Corral. Good. Yeah, I've been trying to address all your comments as well. So I think if anybody sees something that I hadn't tried to address, I mean, again, this spec is meant to be collaborative. I think I only had comments on here, but I'm happy to turn on editing if other people want to be able to edit the spec as well.
Okay, so I have a question. On this case where the network spec contains a plugin string, I'm looking at what you wrote about the revised idea about what goes on std-in, and I'm a little confused still. In the case of pre-result, where would that come from?
Yeah, so what typically happens is, and I'm thinking of this in terms of a chain, and
but where's the chain from?
Right, yeah, chain of network objects.
Right, so if you have there's the question, is if you have a couple of network objects for a particular plugin, so say, or a pod, so say you have a pod and you have, say, 3 different network objects that is supposed to be connected to, should plugins treat them as completely separate and only one of those network objects actually gets its IP address and details referred back to the runtime? Or should all 3 be chained together so that, from network A, the result is passed to network B, which is passed to network C?
I mean, my assumption would be neither.
I think you may be conflating 2 issues.
Yeah,
that's quite possible.
So one is, should they be chained, and the other is what happens, what gets reflected back to the runtime.
Yep.
So chaining, currently, the things that are chainable are built with the expectation that the chain is all applying to one network attachment.
Yes.
And our goal here is to talk about multiple network attachments. So I think it would be a mistake to take chaining and make it apply chaining across network attachments, unless we enhance somehow the chaining concept so that there is some kind of recognition of this 2 levels of structure.
Yep, that is a good point.
Right. A critical part of CNI is ultimately we expect there to be one interface created inside the container, which is to say the one that is defined by CNI IF name, the environment variable. So chain or not, it is sort of all the same, right? You call a chain of 1 or more plugins and you get one interface inside the container and 1 or more IP addresses.
I would point out that the only special case that I can think of there would be the loopback plugin, so that you can keep everything for a container in one config list. You might want to have the loopback plugin be at the top of a chain.
Well, I mean,
but its result doesn't get reflected back into anything.
I mean, really, the loopback should be done directly by the runtime, essentially, right? Because if you're going to put the loopback in a chain, then and you've got a set of 3 networks, any 2 of which might be applied to a container, then you would have to put the loopback in potentially more than one. And then, we've explicitly said that plugins are non-item potent. So I think if you want 3 interfaces, there should be 3 CNI invocations. 3 separate configuration files, 3 separate chains.
I think the confusing thing is that today, CNI actually does tolerate a plugin making multiple network attachments. As long as the user or administrator or whoever is chosen to do this is happy with the fact that Kubernetes will record only 1 IP address, but still wants multiple interfaces, it all just works. But I agree that in terms of what we're defining in the expectations, I'm comfortable saying that's not our design center, and we really are designing for a one CNI invocation makes one interface.
And to be clear, we should probably start simply. And so, yeah, I agree with that definition for the moment. I did update the doc just now to remove that part and only leave runtime config. It kind of brings up the other question, which I was thinking about when Mike was making those comments, was if this is all that actually gets sent to a plugin, then do we really need the plugin option? Or would it be sufficient to have the user just kind of put this boilerplate type and name stuff into the config? And so instead of just specifying a plugin, which is only a single string, make everybody write some stub config with their plugin name, if nothing else.
Mm.
So
Yeah,
it's kind of like
myself.
Simplify the CRD, but make a little bit more work for whatever runtime or meta plugin happens to implement this.
Oh, I see why. Okay, so it's just a way to really trivially create. Well, that makes sense.
Yeah, and I was copying this over conceptually from Joji's doc originally, which I think had also kind of had the plugin option.
Right.
The difference there is that there was no config option because at that point we had been talking about not storing CNI config in the object. And so the plugin part was necessary to handle some of the cases where you didn't want to write config to disk for everything.
Yeah.
So, but if we accept that we can put config in the network object for now, then maybe we don't need the plugin part at all.
Right. But it would be nice to actually have the third option as well, which is config, plugin, and name. Or if that doesn't exist, right, something along the lines of there is a configuration file on disk that the kubelet knows how to reach with name, like storage.
Do you mean file name or network name?
Network name, right? So using the existing logic now that everybody except for Kubernetes uses, that scans for network of name storage.
Right. And I think Corel brought that up in the comments as well. I had specified. Go ahead.
Hey, Casey, how is what you're asking for different from the third and fourth rules in the list?
The third and fourth rules are about file name as opposed to actual network name, because the CNI config JSON has a network name in it that does not have to correlate to the file name. And so originally, I think in Joji's specification and comments that Corel had made, he was expecting that in the absence of a config or plugin key, that the network object name would then be searched for in all of the config files in etc CNI net.d. And I think that's what Casey's talking about as well.
Well, I was actually proposing making the name explicit.
You mean as a spec option?
Yeah, exactly right. Inside this.
So why would we do that as opposed to just use a network object name? Because Kube has the object name, and so it seems kind of odd to me that we'd want to have both a network object name and reference some other name on disk.
Yeah, that makes sense. I hadn't thought that all the way through. Yeah, I think you're probably right.
The one thing that I wonder about now is if we make these things name-spaced, we now have a potential issue with if these things are understood as references to networks that exist in some sense outside of Kubernetes, they might not be name-spaced. And so now we will have a case of potentially two names that are distinguished in Kubernetes by namespace. Well, I guess this doesn't really need to be a problem, because if these things are named after the networks and they don't conflict, we're done.
Yeah, it is a good question, though. And I think part of the reason there is that almost everything in Kube is namespaced. And so there's kind of the expectation that things would be, but I don't think that works as well in this particular case. Right. So I'm not sure what the mechanics of that would be at implementation time if we just leave the namespace blank and it gets the Kube default, or if there's a way to explicitly prevent the object from being namespaced.
I think
I'm lost.
Yeah, I think the CRD supports only the default namespace. I'm not sure it will support multiple namespace thing. So far I worked on CRDs. I'm not sure on this part actually, but the CRD support only the default one.
CRDs are support being namespaced.
Okay, I'm not sure. I mean, so far I worked, it's only on the default namespace actually. I don't know if this will support the different namespaces or not. I'm not sure.
Yes, CRDs are names can be namespaced and not in any namespace.
Okay.
Dan, I'm not quite sure I followed what you were trying to say.
I mean, what I was saying was that, you know, if you namespace something, there is the expectation in Kubernetes that things that don't live within that namespace can't see it. And so, for example, I'm trying to think, you know, at least in,
okay, yeah, I follow the idea, but
right.
that doesn't bother me here, right? I'm assuming that we're going to make these things namespaced, and they'll follow the usual rules. In that these things are references to networks that exist in some other way, right?
Right.
So the reference can be is a namespace and can be found or not and used or not according to the usual rules. The fact that this thing is a reference is a semantic property. It's not, violating anything. It just happens to be a property. When you add a level of indirection, you're adding some features to what happens.
Well, we're getting ourselves in a little bit of trouble, though, because a lot of CNI plugins expect the network name to be some sort of unique key where they can use, for example, local IPAM just creates a directory with the name of the network.
Right. I'm expecting that these things are references to networks that exist, at least in some cases, outside of and independently of Kubernetes.
Yep.
And they have names. They have names outside of and independently of Kubernetes that are distinct. And we will make the thing that makes the references, and we haven't talked about the authorization and the thing that makes the references, but I expect that in these cases, the thing that makes the references will give each reference a name that equals the network name. Or at least that would be one way of solving the problem. There'll be no conflicts and everybody's happy.
Right. Yeah, I guess I was assuming that the network objects would not be namespaced, because that just seems simpler, because the networks exist, at least for the moment, the networks exist globally within Kubernetes. Maybe you can imagine a time in the future when you could actually have multiple that are namespaced and are private to a particular namespace. I don't think that time is now.
I'll tell you, in my use case, the time is now. I'm dealing with something where we have private networks, and we don't give out access. We don't give everybody access to every network. So somewhere there has to be an access control solution. It could be inside Kubernetes using a namespace, or it could be elsewhere.
We have the same thing. We even have parallel networks that are really with overloaded VXLAN identifiers that we separate as different networks in our system because they came from two different what we call pods, or vFabrics, that someone just ran an example and took VXLAN 1, 2, 3, 4, 5.
Can I ask a question regarding one use case that perhaps is fairly common? These networks, these are not really references to typical layer 3 or layer 2 or whatever networks. They are references to plugin chains. So it might be common that you want to have one of these chains available to all namespaces by default, right? And if we namespace the resource, what will be the mechanism to provide these to every user without explicitly creating these references?
So things in other namespaces can be referenced and used by users. Remember, users are just different from namespaces, right? And in Kubernetes, there's this question of what user can access a given object in a given namespace, and we have a standard answer for that, RBAC. So if you want to make a chain that's available, or a network object that's accessible by everybody, just make it accessible by everybody.
I mean, even on the implementation end, it seems likely that most of the naive implementations won't even care about namespace yet.
Well, my question was actually can we have a default plugin chain that can be used regardless of any authorization, any error control?
I would expect that you could have one, just based on how a simple implementation would work right now.
I'm a little surprised by that. I mean, these things are Kubernetes objects, so they're subject to Kubernetes access control.
Yeah, but you have to think about what is the thing that is actually reading the network. And so, you know, you've got a CNI plugin or some kind of CNI service that is talking to the Kube API, and almost always that's going to have some kind of service account that allows it to do more things than a normal user would. So I think at this point, at least, it's not so much a question of access control for that privilege process that would be running potentially on each node, but more a question of how do you find the right network. Because if you're just given a pod and that pod exists in a namespace, and then you're given a list of you know, network annotations for that pod, how do you actually resolve that reference from the pod annotation to a given network name? And so maybe that's a further point that we need to specify in this proposal here is, what does that annotation actually look like on a pod? Does it include a namespace reference, or is there kind of a level of lookups where you look up the network in the pod's namespace first? And if it doesn't exist there, then you look in kind of a global default namespace. I'm not sure what the answer is there, but maybe that's an answer to both of your questions.
Right. I think that's part of the issue. But I think you've touched on a very important issue, right, which is that there are really two issues here, I think. One is, in some sense, what configurations, I mean, there's, what I'm trying to say is, there are 2 points of enforcement that we have that we can use to get what we want done. One is, what configurations of objects can exist in the API server? And the other is, when it comes time for an agent that implements this stuff to read something and do something, what can that agent read? Or what will it enforce for us? I mean, that agent could itself have some logic that enforces some access control. So we have, I think, 2 points at which we can consider, through which we can consider exerting control. But I think, first and foremost, we should decide, I mean, it seems to me, you know, that what's in the API server is really a declaration of desired state, right? And so my natural inclination is to say, let's think about how we can arrange that the desired states, that arrange for the desired control over the possible desired states.
Yeah, and I'd like to obviously point out that I think that we should follow whatever conventions Kubernetes has with respect to access control and namespaces and things like that, and not try to work around it.
Right, and I would also add that that's under, you know, evolution.
Yeah.
There is one interesting summary of ideas that expired and was rejuvenated recently.
There is one POC I remember that this one guy did some POC work on finding the network on a specific network namespace. I didn't follow up that link. I sent out that link in the chat actually. So they have modified the multis in some way, like it will specifically look for the network namespace. And just now I remember this implementation actually. I didn't went through it much, but this implementation is possible, what you're talking about.
I think, as I think about whether or not these network objects or the network spec objects themselves can be named, should be namespaced in the world of Kubernetes, I guess one of the questions is, should users be able to define their own network configs? Because I think those are effectively the same question.
So what you're kind of getting at is, you know, app level networks. And some of the backstory there had been that I think that was something that Tim was suggesting a long while back in November, no, September, whenever that was. Most of this specification for the moment is about cluster admin type stuff.
Yeah.
So adding, you know, more heavily managed sidecar networks on. But I'd like to think that in the future we could do more with kind of app-centric networks.
Yeah, I was hoping we could define a CRD that works for both. Because my
And if we
use,
can, that would be great.
yeah, my use case today is the app level networks. So actually, it's both. So I want both today.
Yeah, I think how I'd envisioned this is for like, the next month or two or so, we kind of try to keep things fairly simple and focus on the sidecar networks, and then try to expand it more in the direction that you guys are thinking, and also
I'm sorry. Maybe I misinterpreted your use of those words. I would use the distinction between provider networks and tenant networks, more along the lines from OpenStack, right? The question is who defines the network. I think maybe by sidecar you were talking versus app, you were talking about, do these enter the rest of the Kubernetes API or not?
I'm talking more about, well, that enters into it, but it's more about networks that already exist, whether they are physical ones. So, think, for example, about a VLAN on the host or something like that, or whether it's a storage network or something like that. Whereas what I thought Casey was talking about was a little bit more around, I'm an app developer and I want to create kind of like a logical network for these two components of my app and another logical network for these other two components of the app, and then somehow potentially connect them together.
Well, I was actually
talking about.
Yes and no. I was speaking a little bit more tactically, which is, there was a specific decision made in network policy that network policies can be created by the namespace administrator as opposed to the site administrator. And the question is the same then. If networks are a namespace object, I think it's the same question, right? Can a network, whatever that means, like can a list of CNI plugins, should that be able to be created by the namespace administrator, or should that only be able to be edited by the site administrator?
Okay. Yeah, it is a slightly different question. Sorry, I misunderstood that.
No, it's a good one. These are sort of overloaded.
Yeah. I mean, obviously it requires that there be files somewhere or configs somewhere or a plugin somewhere that is installed by a cluster administrator.
Yeah.
But
who creates those references? Yeah.
Right. So the Kubernetes RBAC machinery does not itself insist that, there isn't such thing as a namespace administrator, technically. They're just users.
Right.
And Kubernetes is typically installed with a bunch of default authorizations. But we don't have to, by default, authorize everybody in a given namespace to make these things in the same namespace. We could say, for the reasons that Dan mentioned, there's other stuff that goes along with creating one of these. And so we may restrict the authorization to create these to something that is, working with the rest of the system that is beyond the scope of this document to put the whole package in place.
It does bring up a good point, which is, maybe we could suggest a solution here. It may be out of scope for this particular document. And even the...
I was hoping to keep the scope of this document relatively narrow, just so we could get some level of accomplishment and then move on.
Yeah, I mean, from the simpler case, you could say that this can only be created in the kube system namespace, and kubelet or whomever is executing these ignores anything, and that's the end of it, right? That's the simple case. The administrator defines these, and then you can set up a pod security policy that allows which pods can access which networks.
Except that, again, it's not actually the pods that access them. It's the agents that implement the attachments that access them.
Right. It just seems like the pod security policy is the obvious first choice. But again, I'm totally not committed to this. Who gets to decide who gets access to which network? If it's declarative in the pod spec or yeah.
Well, there's this bigger general problem in Kubernetes about these agents that implement stuff and restricting their access to only what they need to know. And I'm not up on all the latest of that, but it seems like this is just hopefully more of the same. But again, maybe I should learn more about that before I say that. But it seems like the first question that I would look at.
So I've also been taking notes at the bottom of the de facto standard document. adding some of these questions. I think they're probably worth discussing a little bit more on the mailing list too, since I think the discussion will probably take a little bit longer. Should we circle back to any of the issues in the proposal? For example, should we even keep the plugin option?
I actually think, I understand now why plugin is there. I think that's a good idea.
Just as like a shortcut?
Bingo.
Okay.
Yeah, I'm not impressed. I mean, if if we take out the shortcut, we can also take a level of structure, and this whole thing just becomes a config.
Yeah, although we may want to extend this later and add other keys later, especially if we start experimenting a little bit more with some of the higher level abstractions that I've talked about and others have talked about.
Right. At which point maybe we keep the level of structure.
Yeah.
I don't have a strong objection to the shortcut. It just seems a little bit odd. Since I guess in my use case, these things are not created by users. These are created by some higher level tooling. So shortcuts serve no real value to the tooling.
That makes sense. No, but the point with using the CRD is to experiment and try out. So we may start with these and then, evolve and then get to some other more. Sorry, I'm messing up. And get to something which is better structured that makes more sense over time. I mean, I think it's a good start. Whether this plugin is obviously not strictly needed, I think it can be folded into config. But if it is a use case where you can simply configure in a simple way something that's trivial, maybe it might make sense keeping it. But I agree with you that it's not strictly needed. It's like redundant information if you want.
Right.
Right, and I agree. I don't have a strong objection.
Okay. I mean, we can keep it for the moment and just heavily specify it to make sure that all the behavior that different implementations have is the same or as close to the same as we can get it. Another question I had was, let's see here. Does anybody have thoughts or opinions on the a requirement that runtimes inject the object name into the JSON configuration that they would then use to execute the plugins? I think Kural had brought that up, and that was kind of a, we already have an object name that's the network name. So why should that be any different from what's in the network config JSON?
I brought this up because it's easy for us, the developers, to debug the issues. If the names are different, it's always confusing me.
Yeah.
If the things are deployed by DevOps guys, it will always confuse the things.
I have a trivial question here, and this might be a really dumb question, but in the config object, we can also have a list of plugins, each one with a different name, right?
No, the config list only gets one name, but you can have different plugins. And actually what happens is if you use the CNI reference lib CNI library, it will actually overwrite the name for each plugin invocation to make sure that the name and the CNI version for all of the plugins match.
All right, perfect. Thanks for the clarification.
Yep, and I think in the CNI spec, it requires runtimes to also do the same thing if they don't use the library. If it doesn't, that's an oversight and I should fix it. So at least the intent is that for every plugin in a given chain, the chain has a name, and that name is then kept the same between all plugins in the chain and sent to the plugin. And there's code in libcni to actually do that kind of injection into the final config that's sent on standard into the plugin.
Perfect. Then the name is unique, and so perfect, makes sense.
Yeah, exactly. Okay, so I mean, if people don't mind doing that, The only objection I had to that was that it does add a little bit more burden on the runtime or the meta plugin. And, you know, it's probably like 10 or 20 lines of Go to actually do the packing and unpacking of the JSON and substitution and stuff. I've written that code already for CNI. I'd like to actually make that a little bit more what's the word for it, callable, or you know, who knows, maybe it can be a public API or something like that. We'll discuss that in the CNI maintainers meetings, but I guess it shouldn't be that hard. So I will make that change to the spec and require runtimes to inject the network object name into the config or the config list when they call. I will leave the plugin option there for the moment. And I will also change the plugin search order sections below and the specification behavior when there is no spec specified to say that the runtime should find the CNI configuration with the given name, not file name. Does that make sense to everybody? I think those are the three outstanding large comments that people had. And just to be clear on the last point, that would bring that behavior back in line with what Joji's original multi-network specification had done.
Yeah, just an FYI, I submitted a PR to the CNI spec to add a IP range capability. So you can, in other words, to put this more sort of like immediately, is that what you can do is you can now pass a range to host local as a config arg, as opposed to having to like write the config directly. So we should merge that on the CNI side.
How do you envision that would be used in a case like this, or with a runtime? Would that
so it's a way to
pull some property from elsewhere or something like that?
Yeah, you can inject the pod decider without actually having to do like JSON rewriting. You can now inject the pod decider the way we inject other dynamic configuration, which is say port forwarding.
Okay, but that would obviously require some runtime changes to send that down as a runtime config option, right?
Yep.
Cool.
Yeah, I mean, like if we want to expose this to the Kubernetes IP allocation mechanism, then I think we're biting off more than we can chew in V1. So, yeah.
All right. Were there any other comments that people had from the call? Any other suggestions or modifications, additions, etc.?
Regarding the part spec annotation part, this one will cover that part, or there will be a separate documentation?
Excuse me. The pod annotations, that was basically an oversight here, and it seemed like originally we had pretty much consensus on those.
Okay.
So I didn't actually specify those in this document, but I added a section at the bottom of the CRD standard document, just kind of a placeholder for that. Does anybody have thoughts on that? Would it basically just be the namespace annotation and then a comma-separated list of networks, I think is kind of how people have done it so far, or should there be any kind of namespacing, or should it be a list, or what?
Yeah, I think that's a big enough thing that's something I thought was a deliberate exclusion from this document. It's a whole nother level of design.
No, it was inadvertent. I think it does need to be specified. Absolutely,
and I would recommend specifying it separately. This is comprehensible and meaningful by itself, and when we get to these other annotations, there's more issues. So, for example, currently we have this is gateway business, which is really confusing two issues. One is, does this network have connectivity to the broader internet? And the other is, what should be the default path out of the pod? And when there was only one network attachment, you could conflate those two. But now when we have multiple network attachments, you can't.
Yeah, and then we're back to the whole problem with overlapping address spaces and how to handle that and so on. So even if you have a route set and someone banks in a network that has the same address, I mean, basically overlaps the address space of the cluster network, then you have interesting things happening.
Oh, well, yeah, I don't think we need to set ourselves up to be required to solve, give meaning to configurations that aren't meaningful.
No, but they are meaningful, because the person that creates the network that sort of extra networks probably has no idea what address space that's used for the Kubernetes control network.
I'm surprised by that claim. I would think that these are all networks being created in service of Kubernetes stuff, and so there should be some.
If you want to run a VNF, right, which is, let's just say, an L3 router that serves someone's networks, you have no clue. So the person that creates this new container that's going to route his networks, he can choose to use whatever network name or address space he wants, right? And the service provider here has sort of taken a piece of network's address space that is used for his Kubernetes network, and there's no way to distinguish that unless you put up a rule and say you cannot use this address space.
Well, look, I mean, it's already the case that, the internet was designed for unique addresses, and when people started abusing it for overlapping private addresses, that abuse only works if each box has a unique meaning for each address.
Sure, but the problem, of course, is that most people use a private address space for the Kubernetes cluster and not public address space, which going to IPv6 might help, because then no one should steal your sort of address space and reuse it, right?
I'm still lost. I mean, look, if you want to forget Kubernetes in virtual, right? If you just want to make a hardware box that does a network function and it's got a control network in some subnet, then you would not expect that box to work with an application or data layer network.
I would actually. Most routers work like that. You can, on the routed interfaces, put any addresses, and you have a completely separate path for the management. So I would definitely expect that to work, and it works on sort of any sort of equipment you buy to forward your traffic.
Okay, fine. Yeah, you can do that in a box because you can put a multiple network namespaces in a box. Right? A Kubernetes pod is one network namespace, right? We don't expect one network namespace to be able to have two different meanings for a given address range.
No, I agree. That is part of the problem. If you want to handle so many sort of VNF functions, you probably need to split the pod into one part that is connected to the Kubernetes namespace and another part that's connected to the customer namespaces, and then use IPv6 link local or something like that in between. Typically in routers, you used to use, say, a UDP socket to communicate between those hops. But I mean, depending on which functions you will implement on Kubernetes, you will either run into this problem or not.
I'm a bit lost about the bottom line of this conversation. Can I ask if this is about the need for Kubernetes operators to be aware of the network topology, of whether this is about the necessity of detailing not the association between pod and network, but between the network attachment and the network? Like, a single pod can have network attachments on distinct namespaces to creating another level of indirection, if we want.
I think it's the latter there. So what we're doing at Kaloom, and I'm not saying this is a typical Kubernetes problem, but it's a typical VNF problem, is that we're building a router, and among other things, a router that's for its control system uses Kubernetes. And then, of course, our system can serve other Kubernetes installations. But a typical problem we'll see that we will run into is that a user in a what we call virtual fabric decides to create 3 networks, and he wants a VRF to route in between them. And then he sets the networks. Let's say he uses 10.10/16 on one, 172 something/16 on another. and they expect it to work. And then the guys that owns the box from us, well, he has configured another network to use internally for the Kubernetes clusters, and there will be overlaps. So when something like this happens and you attach a network, an extra network has the same use the same address space as the internal Kubernetes networks, and starts putting the default router on there, then all of a sudden you change the whole behavior of the sort of Kubernetes, because you cannot separate the address namespace or the network namespace that's used for the Kubernetes control network from the net namespaces that's used for these extra attachments. So it's just rules and sort of and luck that will make it work. Either you have to say that you cannot use these addresses on these extra networks, put in the rules and policies, but you still have the problem with someone say that, oh, the default route should go here. That would force sort of someone for the management network to have the full explicit route map for the management networks set to go for the Kubernetes control cluster network, right? Or we say that no, you cannot change the default network or the default router and put on one of these extra networks, because then maybe the Kubernetes cluster stops working. So as soon as you add more interfaces and you start setting routes, as far as I'm concerned, you need to be able to separate what happens with the quality Kubernetes cluster networks and the provision networks that comes that are added by someone else and controlled by someone else. You need to have a firewall in between that, and you cannot let packages just slip in between, because then you will have chaos.
Well, okay. It sounds like you're trying to do something that is more complicated than a single Linux network namespace can do.
No, yeah, you cannot do this in a single namespace. That's absolutely correct. You need to have two. That's exactly the thing. And as soon as you open up the door to sort of start officially support multi-networking, you start pulling on sort of, I mean, I'm fine with sort of in Kubernetes have either or. I know sort of how we can extend our version that we will run in the system to handle both, but you will have users that start to set routes that will affect everything once you do this.
Can we perhaps
in this pod, you will shoot in a route, right? And all of a sudden, when the file server that was on the Kubernetes cluster network can't be reached anymore, because the address that was used for that is now routed out through another interface. So to me, it's like to bring in multi-network, at least we need to be aware of sort of what all the problems are, and sort of we can discuss what the solutions are. And then we can decide that, no, this is too much, and we will clearly specify that we do not support this. You cannot do this if you're using sort of multi-network. You need to have control of your routes. You need to be aware of sort of what part of the address space is on both sides and so on, and clearly specify it, or go all the way and say that, well, we need to have a way to handle this so that there's no nasty surprise that comes and bites you. And I'm good with either. I'm sort of just sort of that to allow multi-networking before it has sort of been under the cover. So whoever made something and it didn't work, it was the guy that used multi-networking's fault, right? It was never Kubernetes' fault. So if you bring it in officially, then people will say, well, I expect this to work. And it needs to be very clear sort of what you can do and what you can't do.
Can we kind of punt that for the moment?
I'll promise for next time I'll draw some pictures. I'll send something out, and I can even. Suresh is perfect to talk about this because he deals with it all the time, but he couldn't join to it. I'll bring it up and we can discuss it. To me, it's the Pandora's box of sort of multi-interface networking, that you bring in a lot of things that you might not think of from the beginning, and they have nasty consequences.
Could a starting point be for pod annotations that I think kind of like Joji's original document suggested, that the first network listed there is essentially the default one that gets reported back to Kubernetes and gets the default route, or is expected to get the default route?
Yeah, I think
Does that
so.
work for now?
Yeah, I think we could do that. Right. We've got to distinguish network. We got to distinguish detachment. We can let that be by the default.
But it's not the right enough, right? Let's say that you have only one route and it's the default route. So, and let's say that the Kubernetes control network that's set, let's say it's 10.10/16. But any address so let's say that I start using 172, 142/16 on one of these attached networks. If the DNS server that's attached that I get to from the default route points to anything that has the same IP address, even if it's basically just in the service provider's network, you will not reach that. So you will go to something that's on the directly attached network. So for every network that you add to this container with the multi-networking, basically you're blanking out parts that you will not reach through the default route.
Yep.
And you have no clue whether those part of the network is when people are using private networks, if they have been used or not. So if you use correct addresses and never use private addresses, it's not really a problem. But private address spaces and overlapping address spaces, it's like once you start using it, it's like going to be like a Swiss cheese. You create more and more holes that are not reachable, they're not usable in the service provider's network. And they use so much private networks that is ridiculous on the inside of any sort of data center. And so you're going to have a long list for any specific implementation that says like, oh, this network space you're not allowed to attach to the containers directly, because then certain services that you expect to work will not work anymore.
Right. Yeah, I think that's something we should definitely explore further on, because obviously, yeah, I mean, if you attach multiple networks that overlap, it's basically the operator's problem or the person who's defining the pods. And I don't think that's a great user experience. But, for the moment, I hope that it's possible to just kind of start.
You know what I told you, sort of that I think that if you bring all this in one package, people will say, no fucking way. So it's more like, okay, what can we do with multi-networking? How do we box it and explain it in a way that's still useful and usable, because it is, but sort of with sort of the caveat and the rules of how you can use it and what problems are if you go outside of those rules.
So I think there's a very simple, clear box that we should draw. And that is, we're talking about multiple attachments to one network namespace, one Linux network namespace. And everybody knows what to expect from that. They know that overlapping addresses, overlapping subnets in that attachment are, most of those attachments are not going to work, because that's the way the internet has worked from day one.
Yes.
If you want multiple network namespaces, you're talking about, I think you really opened a different Pandora's box, which is something that Kubernetes has kind of touched on, right? Because it says a pod is an assembly of containers that share two of the Linux namespaces and not the others. And that's kind of an arbitrary distinction, right? So I think that's really the thread you're pulling on, is more general assemblies of containers in terms of what namespaces they do not share.
So we will start to work on in a month or two on an implementation so that splits the pod in two parts, sort of the Kubernetes part and another one. We will make it available, but we don't expect to see it upstream. It's just what we need. But it's like you say, sort of that you would have to call it being able to manage the namespaces. But I'll do some slides on it.
Okay, thanks.
Explain sort of where I think, because I think the simple solution would be to say to anyone that's going to use multi-network is, oh, you cannot use private address space on the networks you attach to it. And then 90% of the users would say, then I don't know what to do, because everyone uses it everywhere, unfortunately. Or you would tell the service provider that, oh, you have to specify exactly sort of which address space that you can use when you attach, like pretty much what Amazon does, right? If you create a VPC, you know that you can use addresses from the 10 address space, but don't try to use 172 addresses or 192, 168, because that's what they use internally, and sort of they will not manage them for them. We'll basically just disregard them. I mean, you can go either way, just that each instance would have to specify which address space you can attach. I mean, public address, real addresses, and a subset of the private address spaces, and then you know what you want with it. So some sort of implementation limitations, or no, what do you call it? Not implementation, but instance limitations on the specific Kubernetes cloud. We can play around with all of those.
So what I'll do for now is for the pod annotation, I'll just add some notes about a proposal there for network list with first being default. And then if you have comments, further comments, please add those to the Google Doc, either in the comments section, or again, I can open up the document to full editing from other people if you want, or if anybody wants that. Which I'll just do that now.
Yeah.
So that seems useful, and then people can add stuff to it. All right, it is now editable. Okay, so we got like 4 minutes left. Is there anything else we should bring up, or shall we call it a wrap until, let's see, the next meeting would be the 18th of January.
I think we have only a little bit of time left. Let's just call it a wrap for now.
Okay, sounds good. All right, see everybody in 2 weeks. Thanks.
Cheers.
All right.
Take care, guys.
Thank you, everyone. Bye-bye. Bye.
Thank you.